this is the beautiful Holyoke sludge cake.
That's treated poop.
Treated poop.
What is this structure? What is
Okay.
goes underground? And that's where the sewer comes out?
So yeah, that's the treated effluent from the wastewater treatment plant comes out of that structure and underneath all those trees and riverbank to the center of the river, and then meets
Down the Yellow Brick Road.
down the Yellow Brick Road.
What are we looking at here?
Well, sadly you can't see much, but underneath the water are pumps that are probably 10 feet tall, 350 horsepower each. And we have 4 of them here. Each pump pumps about 35 million gallons of water a day.
And up?
Up, over the wall, and then to our treatment facility, which you can't see yet.
And what is this here? Is that a chimney?
This
yeah.
This is just for exhaust fan for exhausting out harmful
Okay.
gases and fumes, and then this side is the supply air to bring in fresh air.
Okay.
So Natalia, I see you was mentioning the 4 pieces of pipe here and the pumps. What the engineering did is we mentioned how specific some engineering is. The candy cane structure is actually an engineering ploy to reduce the horsepower of the electric pumps, therefore by creating a siphon. So by creating a siphon, once that siphon is developed, it'll pull water rather than having to pump all of the water, reducing the demand of the pump. We are measuring the amount of water that's leaving the treatment plant, and we're also, through the clear tube, we all connect, we're collecting the same. We have our secondary clarifiers, which hold about 1 million gallons apiece, and we're settling out the microorganisms and allowing the clean water to flow to the Connecticut River.
Basically, when we pay our sewer bill, this is where it's going.
This is exactly where it's going. This is maintaining the infrastructure to convey the sewage from your home all the way to the treatment plant, through the process and into the Connecticut River.
And that's no easy task.
It's not an easy task. It's not a short lift. It takes a lot of communication and a lot of education to be able to maintain this complex infrastructure.
And expensive equipment.
Very expensive. You're looking at the headworks building. In here we have our 2 grit classifier separators chambers, and that removes any of the heavy solid rocks and bricks and sticks that may get in, and also coffee grinds and corn. And then from there we screen it with our 2 Duperon fine screens. That'll remove any baby wipes, feminine products, Q-tips, any items that make it into the sewer system that shouldn't be there. And these 2 processes protect all of our downstream equipment. From here, all of the flow that comes into the Holyoke treatment plant is then pumped up to our primary clarification. So all 37 million gallons is what we're designed to pump. Holyoke being a very industrial community, the design engineers, which was Ty and Bond, They designed this infrastructure to meet a high strength waste, therefore using pure oxygen to have the bugs have an oxygen source and reduce our footprint. So it allows the bugs to work very fast in a small space.
Okay.
What you're seeing now is this is our floating aeration mixer. We are through the black hose. We are injecting liquid oxygen, pure oxygen, same oxygen content that you see at hospitals, and we're injecting it into the waste stream to provide oxygen for the bacteria to grow.
Yeah, this reminds me of shallow swampy areas in the tropics with these bubbles.
Yep.
That's where like the little crabs are.
You're off gas. So the bubbles is CO2 is off gassing.
Okay.
The bugs are alive. They have a respiratory system just like us.
That's what I've been telling you.
Yeah,
We're alive.
we're alive. So this is the influent flow chamber. This is where all the flow from the city of Holyoke merges and enters the wastewater treatment process. Here you can see there's 3 pipes that are flowing water. These 2 storage lines are coming from the south section of town. We're going to Springdale and North River. This larger line is coming from the north interceptor, which is starting at the dam, the Holyoke Dam, and running several miles to the plant. And this is the South Street interceptor, which we mentioned earlier, is about 2/3 of the flow.
What do you do with the waste that comes from like the hospital or for people who are taking medications that are very heavy duty, whether it's in pill form or chemotherapy, radiation,
Yeah.
all sorts of things?
So the wastewater treatment plant is designed to remove biochemical oxygen demand and measure that, and also total suspended solids. To remove pharmaceuticals, it either is a participant, or not participant, it is a participate or a soluble. So if it's soluble, we don't have the ability to remove it. That's why pharmaceutical drugs are not recommended to be flushed down the toilet. If it'll precipitate out into the sludge, we are able to remove it as a solid material.
Just of the building here.
Look at them smiling, those guys.
Look at it. The happiest workers ever.
Natalia, I tell you, we put them through a lot, Natalia. They didn't realize as a wastewater operator that they're going to go on video and do content creating. Overcome and persevere. And this allows our staff to view the entire wastewater treatment plant from this office and see pump status, running, pump speeds. You can see gallons of flow. You can see, you have the ability to control the infrastructure here. You can turn on and off pumps as necessary and needed.
Oh, this is like Cape Canaveral.
Sure.
We're not doing rocket science here.
Yeah.
We should get a scene where we all stand up and start.
I'm not sure that Cape Canaveral compares, but So here we have all our different processes, from our pumping to our primary clarification. Here we refer to where the mouse is our biological system. That's where all the magic happens. And then we go to our secondary clarifiers, where we give the bugs a time to sit and relax. And from there, the water that comes off the top goes to our chlorine contact chamber, where we introduce chlorine to kill any pathogens.
Yeah.
And then it would be discharged to the Connecticut River.
Okay.
Okay. And then the rest of these are the different processes that occur here at the wastewater treatment plant.
Does anything look worrying to you right now?
Anything look worrying? Let me scan this before I respond. No, everything is operating currently right now within the predetermined set points that we've asked it to operate within, which isn't always the case. But right now, no, we are in a good position. And the flow looks to be relevant for the expectation of the day of about 7.5 million gallons going out to the Connecticut River. Map, Kev?
What are we seeing here?
These are all the different maps that we have for GIS we track street sweeping,
Field
catch basin
activities,
cleaning. We're starting to track jetting. Let me find the other map.
And we can zoom into the Springdale, just, right, that's the neighborhood I showed for being combined.
All those triangles mean what?
That's just the way the flow goes.
Direction.
Oh, okay.
Yep.
Are you in crew? Alright, now, Kev. You shouldn't be too close there, don't we?
Okay.
Yeah, right there, Kev. So we see Prue in the corner here,
Yep.
and that's what we were showing you earlier on the paper map.
Yep.
Now he can zoom in and out digitally. It's much faster for them, and he can click on some of these tiles, we refer to them, and he can get information on them. If there's information, you can get height, volume, you can get a bunch of details in this. That particular one he clicked on didn't have anything in there.
Yeah.
But you can see that the catch basins, located where it's going, where they tie into the sewer main, and the direction the sewer main is traveling.
And then these, do you receive alerts from these? Or do you have to look at them one by one?
Not that this is a static map, I'll say.
Okay.
Whereas the alerts come from the smart cover technology, and
Okay.
also flow assessment is another technology we utilize.
Okay.
And we have 10 permitted CSOs through the system, and these infrastructure we have set up with flow assessment track and monitor the volume of water and notifies us, and that's how you get your CSO alerts that folks
Yeah.
were getting for a while.
Yeah.
So that's the technology that's utilized for that. I'll show you the mapping of the city of Holyoke here. Let me clear the table. So you were asking how the system looks, and I will go to page 6. And we'll discuss a combined neighborhood, being Springdale neighborhood. So here, when you're looking at the map, you can see a single line drawing, referring to there's just a single line in the street. These single lines are the sewer mains, and the square boxes would be the catch basins. So it's showing you the lines coming down Prue Ave, coming down onto Main Street, and then we're traveling north, and eventually would get to the Springdale pump station. That's not shown on this page. And that is one pipe that's collecting this entire catchment area, including rain.
How wide is the pipe in circumference?
Each pipe is different based on the size of the catchment area. We have pipes in our system anywhere from 8-inch smallest and all the way up to 120 inches. Typically we see 24 to 36 in the larger diameter pipes, but we do have some 48 as well. So
When people flush things such as feminine protection and baby wipes, how does that affect the operations here?
Well, it bogs everything down, and it costs ratepayers, taxpayers, other people to time and money and effort to clear out items that companies are making money on. So we're trying to get them to stop labeling them as such, be more honest, so that we can protect our infrastructure.
this is the debris that we get removed here. And every now and then, we like to refer to it as the treasure box, because sometimes you find money in here. You can find money,
But you gotta put your hands in it to get it.
but it's even scarier the thought of putting your hand in there because we find a lot of hypodermic needles.
Oh.
In wastewater, a primary clarifier removes 30% of the biological and 70% of any inorganics, being scum and grease materials.
What's cool about working in this industry?
Working in this industry is, you know, no 2 days are ever the same. You're always learning. If you're not learning in wastewater, I don't know what you're doing here. Every day is a different day, in the sense that one day you're troubleshooting electrical and why a machine won't operate. Another day you could be dewatering and understanding the importance of removing the water content from sludge. The next day you're running plumbing and mechanical piping to understand how the process is all functioning. So, and then you have the scientists and biological at back end of it. So you can be in the lab looking at the microscope one day and learning what your bugs are doing and seeing how they're growing. It's fun.